I agree with everyone. They were talking about this, like, don't make this more harder than it is. We can see that vector. The x component is just a big old what? 2. Went 2 that way. How far did it go for y? 0. We do that so often in this course. We see vectors like this. We're like, oh, you're just 2 and you're 0. Plus, I think I like to do this a lot with the problems. I think it makes just the mathematics a little bit easier to work with. You don't have to use a calculator as much. I don't think we're going to need a calculator here. Because you know what the cosine of 60 is?
Root 3, 2, right? Root 3 over 2, right?
Close. Isn't it the 1/2?
60 is 1/2, okay.
Very good. So let me just, I'll draw it, don't worry. And here's that special right triangle. We know when that's 60, this is on the trig sheet. The cosine of 60 is the what? Perfect 1/2. The sine of 60 is the root 3 over 2. So 6 times a half is what?
2.
3.
3.
Yep. And then 3 plus 2 is 5. Did anyone see that? All I'm doing is adding these. I'm just going to add this to this. I'm going to add that to that. But a 6 times a 1/2 is 3. 3 plus 2 is 5. Just make it a little bit. That's why I use the angle 60 degrees. If I use 44 degrees, you and I, we all would have what? Yeah, let's get the cosine. You know, it just makes it go a little bit easier. I know you know how to hit cosine 44 degrees on this. Now help me with the other number. Sine of 60 is
Root 3 over
root
2.
3 over 2. What's 6 times root 3 over 2?
3 root 3.
Okay. Now what's its length? What's its magnitude? That was the final way. We're looking for the magnitude.
32 squared.
By the way, look, there's the 5. I'm going to draw this. There's that vector. That's the 5 from here to here. And this was the what? See, it always involves right triangles of Pythagorean theorem. 5, 3 root 3. So to get this, square root of the length, 5 squared, which is?
25.
Now, I know you can do this in your head. I wanted to do it so it's something you can do quickly without even hitting a calculator, but feel free to use your calculator. What's 3 squared? And what's the square root of 3 squared?
3.
So what's 9 times 3?
27.
Oh, we're awesome. Square root of.
52.
Now, hey, I know with the practice set, sometimes I did multiple choice. And so, those answers might have what? The radicals simplified. So what's that simplified?
2 root 13.
2 root 13? Both of these are acceptable though, if it's true response. Both of those are acceptable. Hey, cool. Is there any questions on that? One more thing. Can you find the angle that vector A plus B makes with the positive x-axis? Can you help me find that?
You have to do the
Brilliant. I heard it. What'd you say?
Use inverse.
Brilliant. He goes, just use inverse tangent. Because look, do you see the triangle? Can you find, this is actually to find the angle that this vector, this new vector we just found, there's its length, there's the components. And we're like, can you find this angle here? We can just call it theta. He says, well, that's just a right triangle. Tangent of theta is TOA. So he's like, to get the measure that angle, he says, use inverse tangent. So that would be the formula for this. He says, just do inverse tangent, and then when you got to do the y over the x of these components. There's your y, and this is the what? X. So I'm going to leave my answer as 3 radical 3 over the 5, right? TOA. If you want the actual degrees, put that on your calculator. Just make sure you're in degree mode. It'll put it in degrees. You just type it in like that. The TI-83s and 84s, it does put a parentheses here. So you're going to want to close out that parentheses if you type it all in like that. Sound good? But I think sometimes you're going to run on the practice set. I like my answers like this. But there's my angle. You want to find out what it is, you use the tool, the calculator, to figure out what that number is. Cool? Hey, is everyone okay with that? Hey, just a couple more things. I just wanted to at least get into, because we did 12.1 and 12.2, right? I just want to introduce what we're doing next class. Because we did, here's 12.1 and 12.2. For next class we can do 12.3 and 12.4, right? Then we can do 12.5 and 12.6. Basically two sections. So, one day, another day. You know, if we can do 3 sections in a day, that's fine. 13.1 and 13.2, and then finally what? Just to give you an idea. But how many days will this take? All right, here's Monday. That's one class. Tuesday, Wednesday, what? Thursday. And this is still a what? Monday. That's what I mean. So it gives us enough time before your first test to cover everything from what? 12 to 13. Next class, what are we doing? We'll be starting section 12.3, and it's on the dot product. Okay? It's on the dot product. Has anybody ever heard of that before? I'll stand. This is huge, so I just want to talk about the dot product. If you got to find the dot product between two vectors, don't worry, we'll do this next class, but I just want to introduce it before we break apart here. The dot product of two vectors, A and B. The result is a scalar value. So the dot product, let's just say one vector was 1, 2, -3, and here's vector A. Vector B is the vector 4, 0, 2. And you've got to find the dot product between these vectors. What do you simply do? Because the math formulas, that was brilliant, and I heard other people know this as well. They say you just multiply these components, multiply these components, multiply these corresponding components, and between them all, you add them up. So the definition would be this times this, plus this times this, plus this times this. And it's just the definition. That's what we call the dot product of A dot B. A lot of times you can do it mentally. But I do want to point out the dot product, and when you just put a dot between these, the dot product of two vectors is not a vector, is it? So that's why I just want to end class making sure everyone understood that. We go, okay, we're going to find the dot product between two vectors. Well, the dot product of two vectors is not a vector. The dot product always comes up to some scalar result, like a 3 or something like that, or 0. True? What is the dot product? What's 1 times 4?
4.
Plus 2 times 0. I love zeros. Plus
-6.
So what's our answer?
-2.
Cool. So we'll start next class with that. No mean the first day to rush into that. We'll do a separate day for that. Dot product's cool because if the dot product is like 0, it's telling you so much about the vectors. Does anybody know what it tells you? If you get a dot product of two vectors being 0, if the two vectors are actually perpendicular to each other. So this is tomorrow's. I just want to point that out. If you're sitting there going, why is this important? The dot product is huge from chapter 12 to chapter 16. It gives us so much information. One big thing would be if it was 0, we know the two vectors have to be 90 degrees from each other. Whether they're 2-dimensional or 3-dimensional. Hey, great job, everyone. Have a great day. If you have any questions, stick around. Hey.